Let's get started. Is there any question before we talk about Lab 12? Okay, then let's talk about Lab 12. Okay, so today is experiment 12, which is about delta. Okay, so the delta is the first nonlinear component we learn from this semester. So you try to study about resistor, capacitor, and the inductor before. They are all linear circuit. If you remember, you verify the Ohm's law for all of them, or at least the resistor and the capacitor. So, but for the delta is it will be a nonlinear component. Okay, so for example, here is a example of the IV curve of the delta, and it's follow this this equation right here. Okay, let's use my PPT right here. So first of all, as I mentioned, the delta is a nonlinear component, and the second property of the delta is it has a forward and reverse bias region. So when the voltage at positive side is greater than the negative side of the delta, it is in forward bias region. Okay, then for another, when the voltage at this side is smaller than this side, the negative side, then that's in reverse bias region. Okay, and also it has a turn-on voltage. If you back to the plot right here, when the current start to increase exponentially, okay, that voltage is usually we call turn-on voltage. Okay, and also there's a breakdown voltage, which means if you put a very large positive voltage on the negative side, that could cause the breakdown of the delta, so that will make the delta burn or something. Then it's just broken. The delta will just broken. Okay, and here is the plot indicates the polarity of the delta. Okay, you will see this the delta looks like this in your lab kit. Okay, and for this week you're going to try to play with three kind of delta: the PN delta, which is 4148, the Zener delta for 5226, and the Schottky delta 5819. Okay, if you I will send this picture on the Brightspace, you will see those three delta looks like this. Okay, so this one is clear that's for 5819, which is the Schottky delta. Okay, and the Zener delta and PN delta looks similar, but you still will see if you zoom in, there are some number on the delta, so you can distinguish between those two delta. Okay. It's a little bit hard to say, but you should able to see the number on this part. Okay. And also this little strip you see right here, the black strip on this too, that's indicated the polarity. Okay. All right, so that's the basic knowledge of a delta. There are many functions of delta, but for this lab, we will firstly learn learn how to measure the IV curve of the delta first. Okay, let's jump into the tasks. Okay, remember there are two pre-lab tasks. Okay, so the first one is the Q&A, and the second one is the experiment. You need to build this circuit on the breadboard. Okay. Okay, then task one. Okay, task one is also just a Q&A. You just need to answer the question for these two, and you don't have to write a objective and conclusion for task one. Okay, so you just answer these two questions. Okay, the instrumentation amplifier is INA 1 to 1. So try to look for the datasheet of this one. You should able to find more information related to this amplifier. Okay, then the task 2 is where you need to start to build the circuit on the breadboard. Okay, first of all, you're going to build this circuit right here. Okay, on the breadboard. But since you're using AD2, as I mentioned before, AD2 can directly read the differential signal. So you don't have to build this instrumentation amplifier here. Okay, so you can just ignore this amplifier. So what you will need to do is you can put the oscilloscope positive pin, the negative pin to here. Then the oscilloscope can directly read the differential signal from your AD2. Okay. But before you build this circuit, you will need to calculate the value for R limit and R sense, right? So how to calculate this value is actually already given in the menu. Okay, so the R limit plus R sense should be greater than this equation right here. For the RS, since again you're using AD2, RS is equal to 0, so you can ignore about RS. And okay, so for the Vmax, okay, Vs maximum, if you check the question here, the tasks here, the Vs maximum is already given in the question. Okay, and then if you back to here, the ID maximum is also already given. Okay, so that's 30 milliamp. Then you need to find the VD test according to this current. Okay, so you need to go to figure 12.9. Actually, that's a typo in here. In the line menu is not 12.9. You will need to look for this figure right here, okay, which is 12.5. Okay, so you are going to find the corresponding voltage according to the given current here. Okay, so after that, you should know Vs maximum, VD test, and the ID maximum. Then you can calculate this equation. Okay, then the R limit plus R sense should be greater than a resistance. Okay, so then for the R sense, you can pick from 101 or 1K to make the calculation easier. And then you pick the R limit. Make sure the R limit plus R sense just satisfy this equation. Okay, so for example, if you have R limit plus R sense greater than 200 ohm, okay, then you pick R sense 100, then you pick R limit, let's say 1K, okay. Theoretically, you still satisfy this equation, you still limit the current, but what will happen is you limit the current too much, okay, because 100 plus 1K, that's 1.1K, so that's too much larger than 200 ohm. Okay, 200 ohm again is not the real result. I just gave an example. So you limit the current too much. If you check the following question right here, you need to place a marker when the voltage reach 10 milliamp. Okay, what will happen is if you put the R limit too large, the current can never reach 10 milliamp, similar with other questions. Okay, so make sure your R limit is just satisfy the equation. Okay. All right. So after you calculate the value and pick the value for R limit and R sense, then you can build the circuit, and you will use one of the channel measure R sense, okay, and another channel measure DOT, which is the diode here. Okay, so that's the two channel you're going to measure, and you will see probably a weird time scale plot. But then what you need to do is you need to transfer to XY plot. Okay. So after you plot the XY plot, you will see something similar as we mentioned in the lab menu. You will see something close to this. Then that means you did the things correctly. Okay, if you get some weird plot, then that means something wrong with your circuit. Okay, the most common mistake in here you may make is you may inverse the channel 1, channel 2. Okay, again, when we plot the XY plot, we always, when we plot the IV curve, we always want the voltage at, where's that? Voltage at x-axis, right here, and the current at y-axis, okay, like here, which means in the circuit, the voltage cross the DOT, that will be the x-axis. Okay, the voltage cross the R sense, then you divide that voltage by R sense, then that's the current. Okay, so the current will be y-axis. Okay. Then if you back to the tasks after you get the plot, okay, you will need to export the data again, which is similar with the last time. What's the difference is last time you plot the time scale and the channel 1 or channel 2. But this time, after you export the data from to the Excel or whatever or MATLAB, you will need to plot the channel 1, channel 2 as your axis, okay? Because you want the IV curve. Right. So for task 2, step number 1, you're going to task the 4148 delt, which and then you're going to put 2 delt in series, and you're going to plot them again, and also export the data again. And then you will put 2 IV curve in the same axis, okay, and then you will see what's the difference from one single delt and 2 delt in series. Okay, then step number 2, you just answer the question here, and the step number 3 and the number 4 basically are similar with the step number 1. Okay, so on here, I would suggest you use MATLAB because it's easier to put a marker in MATLAB. Okay, you see this step, you need to put a marker in the plot. Okay, and for step number 4 here is asking you to generate the IV curve on the AD2. Okay, it just says to capture a screenshot, but actually you do need to export the data. Okay, you don't need to show the data in this task, but you will need the data for the last task. Okay, so make sure you export the data for all 3 delts. Okay, and then after you plot all the XY plot, you can put them together and check what's the difference between each delt. Okay, then you are able to answer the question for step number 5. All right, so I think that's task 2. Any question for task 2? Okay, if not, the task 3. Task 3 should be pretty simple. It's about delts and lot lines. Okay, so first of all, how to draw the lot lines. Okay, so this is a circuit you are given. Okay, so how to draw the lot line is, first of all, you find what's the open voltage, okay, which should be just 5 volts. Then you can find the short current, okay, which means when you short here, okay, what's the current goes through this point. So that's your short current. Okay, then you put these 2 points on the IV plot, and then you connect these 2 lines together. Okay, this line will be your load line. Okay, so that's one of the method you can plot the load line here. And then after you plot the load line, and you're going to okay, so that's one of the reasons why I suggest you use MATLAB again, so you can easier put every plot together. So after you have the load line, you're going to put the every curve of the 4148 delta and the 5226 delta into the same graph, okay, or same axis here. And you're going to see something like this, okay. Then this point right here, that will be your operating point. So that's how you predict the operating point right here. Okay, so after you get the plot right here, you're going to build this circuit on the breadboard and measure the DC voltage of the diode. Okay, then you can verify the measured operating point with your predict operating point. They should be very close together if you didn't make any mistake. Okay, let's see. Again, there are a couple common mistake here. The first one, make sure your voltage should be on X axis. The current should be on Y axis. Okay, and make sure your R limit is not too large, so that you didn't limit the current too much. And then if your plot for second task looks weird, so for example, the plot suppose looks like this, okay? But if your plot looks like this or something else maybe looks like this, try to inverse your channel 1, channel 2 to see is it get fixed. Okay, and okay, another thing here is make sure when you plot the current, okay, you need to make the voltage at R sense divide by the R sense value, then you can get the current. Okay. Otherwise, if you just directly plot channel 1, channel 2, that's the voltage cross DOT and the voltage cross R sense. Okay, so that's the VV plot, not the AV plot. Okay. Right, I think that's all for this week. Any questions? Okay. Okay, should be this week's lab shouldn't be too hard. Okay. Okay, if there is no question, you can start the experiment, and I will open the breakout room again. Yeah, let me share the delt picture in the Brightspace. There are a couple questions asking about what's the circuit they're going to use for the task 2. Okay, let me share my screen in 1 second. Okay, so this is the circuit you're going to build for the task. Okay, it's already given in the menu. Okay, so that's how you can build the circuit and measure the IV curve. But before you build the circuit, you need to calculate the R limit and R sense, right? So the equation is also already given in here. So let me use my PPT right here. So that's a circuit and that's the equation. Okay. So all the value you need is actually already given. Okay, so first of all, RS is just 0. Okay, because you're using AD2, RS is 0. And we uh, Vs maximum, so that's the source voltage, maximum of source voltage. So if you check uh, the experiment, it's also already given. The Vs range is from -4 to forward, okay, then which means maximum is forward. Okay, then let me use a pencil. Okay, so this thing is already given. Then the ID maximum, okay. If you check the menu again, ID maximum is actually also given. So that's 30 milliamp. And then how to find the VD test. Okay, so you are going to find the figure 12.9, and which is a typo here. If you check your menu, it's actually, or if you check the menu on the Brightspace, it's actually 12.5, which is this figure right here. So if you use the given current 13 milliamp, then you can find the corresponding voltage, okay? Which means you have all the value you need, okay? Then you can find the R limit plus R sense will be greater than greater than a value, okay? Then you can start to pick the value for R limit and R sense. So R sense is better, choose from like 110 or 1K. So that's easier for your calculation, because eventually you will use the voltage divided by the R sense, then you get the current. Okay. Then for the R limit, okay, so after you choose your R sense, your R limit plus R sense should just satisfy the equation. Okay, so for example, if you're after you do the calculation, you get R limit plus R sense greater to 200. Um, uh, then you make sure your R limit plus R sense just greater than 200 a little bit. Okay, if you choose R limit plus R sense to be like 1K, then you limit the current too much. You will not get the whole plot. Okay. Um, okay. Then okay. After you get the R limit and R sense, you can build the circuit, right? You're not going to use this ampere here since you're using AD2. So what you can do is you can use directly use the oscilloscope to measure the voltage across R sense. Okay, so let's say that's if you choose channel 1 measure R sense, so that will be 1 plus. And then you put your 1 measures right here. Okay, then you can measure your the signal across R sense. And then you can use channel 2 uh, to measure the DUT. Okay. Okay, so that's how you calculate the value and how you build the circuit and how you can use oscilloscope to measure it. Okay, let me see. Okay, there is a question about what's the horizontal and vertical input of the oscilloscope mean. The horizontal is just the XY plot, right? Let me share. Okay. So after you get this plot, after you get this circuit work, okay, so you are going to use XY plot. Okay, so what's XY plot? If you remember correctly, so you use one of the channel as X axis and Y, and another channel will be Y axis. Okay. Ideally, it should be channel one as axis and X axis, and the channel two as Y axis. So the horizontal plot should be, what's in the question again? So the horizontal input should be the X axis. Okay, the vertical input should be the Y axis. Okay, and remember the X axis should be voltage, right? The Y axis should be current. Okay, so how you can get the current and voltage is the voltage should be the voltage across the DOT. Okay, so which should be the channel 2 in here. And how you can get the current of the DOT is you're going to use the voltage cross channel 1, or voltage cross R sense, and use that voltage. So which means VR sense. Let's say we are okay. And use this voltage divided by the value of R sense. Okay. Then you can get the current of R sense, okay, which is same as the current of DOT since they are in series. Okay, so that's how you can get the average curve. But first of all, after you build the circuit and if you plot the XY plot, you should see something like this. So that's the average plot should looks like. And again, so that's if you look this should be familiar because this is similar with this plot right here. Okay. Okay, and I saw there's a question about R limit. Okay, let me repeat the R limit again. So let's say after you do the calculation, okay, so let's say your R limit plus R sense is greater than 200. Okay, again, this is just an example. Okay, 200 is not the answer of this equation. Okay, so then you can start to pick R sense first. Okay, let's say you pick your R sense is equal to 100. Okay, then you're going to pick your R limit. Okay, if you put your R limit as 1K, okay, that's theoretically that's still work for this equation, right? Because 1K plus 100, that's 1.1K. 1.1K is greater than 200. But what will happen is you will limit the current too much. Okay, you will never see the enough, or you will never see the whole plot it wants here. So in that case, don't choose 1K. Okay, probably you can choose like 110 ohm. So that will be 210 ohm if you plus them together. So that's just over 200 a little bit. So that will be fine when you get the plot. Okay. So that's how you choose the R limit. Any questions? Any other questions? Okay. Yeah, if you're still confused about this, I can help you in breakout room later.